other things that you need to cover in this chapter of atomic structure. You should know the history of atoms, like what developments were made that has given the present structure of the atom. What is the present structure of the atom? How do we do the electronic configurations, and what are ions and isotopes? Okay, so let's begin. Now, when we talk about the history of the atoms, there are 5 major scientists which names you should remember and what contribution they did in the discovery of the atom. The first one was the John Dalton, who gave the idea of atoms in the early 1800s. Then came J.J. Thomson, who discovered electrons after Dalton, and he gave the model, the plum pudding model of the atomic structure. Then after J.J. Thomson came Rutherford. He discovered the nucleus by alpha scattering experiment, and then came the Niels Bohr, who gave the idea of electronic shells in 1940, and then finally came James Chadwick, who discovered the neutrons in 1932. So we got the first idea about the atoms in early 1800 by John Dalton, and after 1932, we came up with the final structure of the atom. So let's look at these contributions one by one. So in early 1800, there was John Dalton, and he said that everything that has mass or volume is made up of atoms, and you cannot divide atoms further. Late in 1800 came another scientist called J.J. Thomson. Now what he did was, he took a glass tube, and in this glass tube, he kept a gas at a very low pressure. The gas tube had a cathode and an anode, and it was given a very high voltage, around 150,000 volts. Now, at such a high voltage, he saw that the glass tube, it gave a green glow. And from where did the green glow came? It came from the rays that was given out of the cathode. Now, he called these rays as a cathode rays, and as they were coming towards the positive terminal, he concluded that these are the negative rays which are coming out of the gas atoms which are present in this glass tube. So he discovered that atom can further be divided, and it has a negative and the positive charged subatomic particles. On the basis of that, he gave this plum pudding model. Now, what was this plum pudding model? This plum pudding model says that atom is a sphere of the positive charge. The positive charge is equally distributed, and in this sphere of the positive charge, the electrons are embedded as raisins, and he gave the plum pudding model, and according to him, the electrons and the positive were similar, therefore atom is neutral. Now, if this model was correct, at that time, there was another scientist called Giger and Maston, which were doing the alpha scattering experiment. So what did they do was, they took a gold foil, and on those gold foil, they bombarded the alpha particles. Now, what they predicted was that if plum pudding model is correct, then majority of the alpha particle should pass undeflected from this gold foil and should hit the zinc sulfide screen. But to their surprise, what did they find was that majority of the alpha particles went off undeflected, and there was minor deflections, and at the center there was a greater deflection, and some of the alpha particles, they just bounced back by 180 degrees. Now, what does this tell us? It tells us that since most of the alpha particle pass straight through, majority of the space is empty in the atom, and since there was a greater deflection at the center, there's a positive charge which is concentrated at the center of the atom. So therefore, Rutherford modified the structure of the J.J. Thomson, and he said that the positive charge which is concentrated at the center is the nucleus. So he refined the structure, and he said that there's a nucleus at the center which is consisting of the positive charged elements, positive charged subatomic particles, and then the electrons are revolving around this nucleus. Then came another scientist called Niels Bohr in 1914. He gave the idea of electronic shells. Now, what he observed was, whenever an atom was given any energy, it was emitting this specific amount of energy. So what was happening is the electrons which were orbiting, they were taking those energies, and then when they were coming back to their ground state, they was emitting the energies. And these energies were of the specific amount. So he concluded that electrons are not just orbiting anywhere around the nucleus, they are orbiting at the specific energy levels called the electron shells. Then there was another scientist who came in 1932 called James Hardwick. What was the observation was, when they were taking the mass of the neutrons and the mass of the protons, there was a mismatch. Although the atom was still neutral charge-wise, but there was different in masses. So James Hardwick discovered that there's a third subatomic particle present called the neutrons, which has no charge, but has the mass similar to that of protons, and that is present inside the nucleus along with the protons. Okay, so with all these discoveries, we came up with this structure of atom. That atom is composed of 3 subatomic particles, and this table is very, very important. You should remember each and every part of this table. You might be asked in the exam to either fill some parts of the table or maybe to make this whole table. So the atom is made up of 3 subatomic particles: electrons, protons, and neutrons. Electron has a relative charge of -1, protons have +1, neutrons have 0 charge. The relative mass of protons and neutron is 1. Electron is 2000 times less. Therefore, electrons are lighter. Proton and neutrons are found in the center, in the nucleus of the atom, and the electrons are found revolving around the nucleus in specific shells. So you can see that this is the element which has 4 electrons. So 2 are in the first shell, 2 are in the next shell, and 4 protons and 4 neutrons are in the center. This is how we make the structure of the atom. Now, how do we work out how many proton numbers, electron numbers, or neutron numbers are there in an atom? For that, we take the help of a periodic table. If you see the periodic table, in the periodic table, all the elements are there with their symbol. So this is the symbol of the element, and they'll be having one number at the top and one at the bottom. The number at the top is the mass number, which is the number of protons and neutrons. The number at the bottom is the atomic number, which is the number of protons. And since atom is neutral, so the number of protons and neutrons are the same, so the bottom number will also give you the number of electrons. So if you need to work out the electron number, you will write the bottom number. If it is an atom, remember, it has to be an atom. Then only you can say it has an equal number of electron and proton. We'll see later. There's a second category called ions, which have unequal number of electrons and protons. The proton is again the bottom number, and the neutron number is the top number. Take away the bottom number. So that is A minus Z. Okay. Next is, when we have the electrons, they are filled in a specific energy shells. So the first shell can hold maximum of 2 electrons. The second shell can hold maximum of 8. Third can hold 8, and fourth can hold 18 electrons. So if we talk about sodium, whose atomic number is 11, then you will fill them as 2 in the first shell, 8 in the second shell, and 1 in the last shell. Similarly, magnesium with the atomic number of 12 means electron number is 12. Will have 2 in the first shell, 8 in the second shell, and 2 in the final shell. Okay, so our electronic configuration is clear to you. Now you have in your syllabus the electronic configuration of the first 20 elements. So this is the list of the first 20 elements. So hydrogen, helium, lithium, beryllium. The atomic number is mentioned. So electronic configuration with 1 atomic number would be 1. With 2 is 2. Then 3, we'll have a new shell, 2, 1, 2, 2, 2, 3, and so on. And once all 8 electrons are filled in the second shell, with the sodium, we have another shell. So with 2, 8, 1. So this is the electronic configuration of the first 20 elements. Now, electronic configuration is very useful. Why? Because electronic configuration gives you the information whether the electrons are fully filled in a shell or not. If the electrons are not fully filled in each shell, the elements will react in order to gain full outer shell. The number of electrons in the outermost shell gives us the group number of the element. So lithium belongs to group 1, beryllium belongs to group 2. Lithium and sodium, they both have 1 electron in their outermost shell, therefore they belong to the same group. Okay, so by looking at the electronic configuration, you can get that much of information about any element. The other information you can get by looking at the electronic configuration here is that helium has the complete first outer shell, neon has complete second outer shell, and argon has complete third outer shell. These three elements do not have any capacity to take any other electron, therefore they are noble gases. Why? They have full outer shell, therefore they do not have to react further. On the other hand, to react, to be stable, sodium has to lose one electron so that it can get a full outer shell configuration. On the other hand, chlorine has to gain one electron in order to get full electronic configuration. So this is how we analyze the electronic configuration, and these are all the informations we can get from that. Okay, so I hope it is clear to you. Now let us move on to what are ions. Now ions are charged atoms. Charged atom means they have unequal number of protons and neutrons. And how this unequal number of protons and neutrons arise? Either by loss of electrons or gain of electron. If any atom loses an electron, it will have more protons than the electron, therefore it will get the positive charge. And if any element gains an electron, it means it will have more electrons than the protons. An atom that gains an electron will get the negative charge. Okay, now how you decide the charge? The charge depends on how many electrons are gained or lost. So if sodium has lost one electron, it will get a +1 charge. If magnesium loses 2 electrons, it will get +2 charge. In the similar way, if fluorine gains 1 electron, it becomes -1 charge. And if oxygen gains 2 electrons, it will become -2 charge. Okay, now let's see how the electron number changes with the ion. Now this is the sodium. You know the bottom number is the electron number. The top number, take away the bottom number, that is 12, will be the neutron number. Now sodium becomes sodium plus, means it has lost 1 electron. Now since it has lost 1 electron, the electron number will be 10, but the proton number, neutron number remains the same. Okay, so there's always a change in the electron number whenever the ion is formed. Similarly, oxygen 8 and 16, they all have 8 proton number, neutron number, and electron number. When it becomes 2-, it means it has gained 2- means gained 2 electrons. So you add 2 to their number of electrons and that becomes 10. Okay, so I hope you are now in a position to work out the proton, neutron, and electron number of an atom and an ion. Okay, so now let's take an example. Now you can see that I have made 3 tables. In one, I have put a sodium atom, and since it is an atom, it will have an equal number of electron and a proton number. I have added aluminium 3+ ions. Since it's a 3+ ions, it means it has less electrons and more protons, and oxygen 2- means it has more electron than the proton. Now you will follow the same tactic. The bottom number is the atomic number. So I've put 11, 13, and 18 in all the 3 boxes. The top number is the mass number. So 23, 27, and 16. The proton number is always the bottom number. So that is 11, 13, and 8 for all of them. And neutron number is the top number. Take away the bottom number, which is 12, 14, and 8. Now the first case is an atom, so it will have an equal number of proton and neutron. So I'll fill 11 in this column. But in the second case, the proton number and electron number will not be the same because aluminium has lost 3 electrons. So if it would have been an atom, it should have 13 electrons, but now it has lost 3 electrons. So 13 - 3, it now has 10 electrons. In the oxygen case, it should have 8 electrons, but now it has a 2- charge. It means it has gained 2 extra electrons. So now it has a 10 electron. Okay, so the charge is the proton number. Take away what is the charge of the proton and the electron. So here it is an equal number. So it is 0. Here the charge is +3. Here the charge is -2. Now electronic configuration, since the electron number is 11. So 2 in the first shell, 8 in the second shell, and left over 1 in the third shell. These both have 10 electrons. So 2, 8, 2, 8, full outer shell configuration you will have for all these ions. Okay, so I hope you are able to do this because these questions are often asked in the exam where they give you an element and they ask you to work out the atomic number, mass number, electron number, proton number, neutron number. So make sure this table is clear to you. Okay. Now, next is the last concept. What are isotopes? Now, if you see in this, I have made 2 tables. They both have carbon. with the same bottom number but different top number. Now, since the top number is different, the atomic number is the same for both of them, electron number is the same for both of them, proton number is the same. Now, what changes is the mass number, which is 12 and 13, and since the mass number changes, the neutron number changes. This is what is the concept of isotopes. So isotopes are the members of the same elements having same atomic number but different mass number, same number of electrons and protons but different number of neutrons. So since they have similar electronic number, they show similar chemical properties, and since they have different masses, they show different physical properties and radioactive properties. It can happen one of the isotope is stable, other is radioactive, and this is all because they have different masses. So you should know the definition of isotopes, what things are same, the similarities in the isotopes. They can ask you what are the things similar in the isotopes. So you can say atomic number is same, proton number is same, electron number is same. What is the difference in the isotope? The mass number is different, neutron number is different, physical properties are different. Why chemical properties are the same? Because the electron number is the same. And for the chemical reaction, it is the electrons that takes part. Okay, so I hope the concept of isotopes is clear to you. Now, this is all you need to do in this topic. So now here I have tabulated the important key terms of this topic. So in this topic, we have seen what an atom is. It's the smallest particle, consists of electron, proton, neutron. What is a proton? Proton is a positively charged subatomic particles with a relative charge of +1, relative mass of 1 found in the nucleus of the atom. Neutron is a neutral subatomic particle with the charge 0, mass 1, relative mass 1 found in the nucleus. Electron is negatively charged with relative charge -1, relative mass 1/2000. Remember that table, and which is found revolving around the nucleus in shells. Nucleus is the center of the atom with the positive charge, which contains neutrons and protons. Atomic number is the number of protons. Mass number is the number of protons and neutrons. Ions is a charged atom with unequal number of protons and neutrons. What are isotopes? Members of the same element with similar number of electrons and protons but different number of neutrons. Electronic configurations is arrangement of electrons in shells. Okay, so I hope all these key terms in this unit is clear to you. So now let's test yourself. So the first question is you need to give one word of what are the positive charged subatomic particles, the negative charged subatomic particles, electrons was discovered by, neutrons was discovered by, and what was the name of the model given by J.J. Thomson. Next is you need to answer how to work out the neutron number of any atom. What do elements in the same group have in common? Why isotopes have similar chemical properties? And you need to draw the structure of calcium atom. So you can pause the video, have a go at these questions. Okay? Right, so now let us look at the answers of them. Positively charged subatomic particles is proton, negatively charged is electron. Electrons were discovered by J.J. Thomson, neutrons were discovered by James Hardwick. The model given by J.J. Thomson is plum pudding model. How to work out the neutron number? It is a mass number, take away the atomic number. So top number minus the bottom number. What do elements in the same group have in common? They have same number of electrons in their outermost shell. So for example, sodium and potassium both belongs to group 1, have 1 electron in their outermost shell. Why isotopes have similar chemical properties? Because they have equal number of electrons, so they show similar chemical properties. Next is to draw the calcium atom. Now calcium is 40 and 20, so it means electron, proton and neutron number all is 20. Electron configuration will be 2882, so we'll draw a calcium atom. I've just drawn a tiny nucleus. You can draw a bigger nucleus showing 20 positives and 20 circles with no charge. So I've written 20p and 20n, and then you have to show 4 shells. 2 electrons in the first shell, 8 in the second, 8 in the third, and 2 in the last. Now, when we talk about the development of the periodic table, it took a lot of years to get the periodic table in the form which we have now. It started all around in 1808, where there was a scientist called John Dalton, and he published a table of elements, and he simply arranged the elements in the order of increasing atomic weights. There was no pattern, no similarity that was detected, so his idea was completely rejected. Then in 1864 came another scientist called John Newland, and he gave the Newland Law of Octaves. Now, what he did in that was he arranged the elements according to their atomic weights. And what he found that there was a similarity in the first element and the 8th element, like the octaves.
Now, his idea was okay as it worked well up to calcium, but majority of the elements were not discovered at that time. So his idea of the first and the eighth similarity did not fit with all the elements. So that was also rejected. Then a biggest revolution came in 1869 when a scientist called Dmitry Mendeleev, he also arranged the elements according to atomic weights, but he found patterns of similarities within the elements because he left gap where the elements did not fit the pattern. So in this way, he organized the similar elements in the similar groups, and where the gaps were left, they gave us the pathway to discover the new elements. And using his idea, there were many new elements that were discovered. But again, that was not that effective because not all elements fit into that pattern. So argon, it was one of the shortcomings that argon, which had a relatively greater mass than potassium, should be placed before potassium. But if we do like this, then the argon will be placed in the group of sodium, and lithium and potassium will come in the groups of noble gas. So that is not a trend in the properties. Many other elements were also found not fitting this pattern, and Mendeleev swaps them in order to maintain the periodicity, but his periodic table was not universally accepted. Now, the present periodic table now overcome all these shortcomings by organizing the elements in the order of increasing atomic number or the proton number. So all the problems that were due to dissimilar atomic weights were all corrected by this. And when we created the elements in the form of atomic number, we came to know that the difference in masses of some of the elements is due to their isotopes, because there are many different isotopes an element can have, and the atomic mass is the average of the isotopic mass of all its isotopes. Okay, so this is how we came to this form, which is a present periodic table. Now, just looking at this modern periodic table, there are a lot of things that you can easily find out. First of all, from this group 13, we will make a zigzag like this staircase. All the elements that comes into the zigzag are metalloids or the semi-metals. All the elements which are left to that are all metals, and the elements to the right are the non-metals. So if someone asks you, give an example of any metal, you can pick any one from this group. If somebody asks you, give an example of a non-metal, you can easily pick any from this group. What is a metalloid? You can easily pick one in this zigzag. Now, the last group is a noble gas. Now, we'll see when we do the electronic configuration of the noble gas that it has full outer shell electronic configuration. As a result, noble gases are given the name noble gases because they do not react. The elements in the same group will have the same number of electrons in their outermost shell. So in the group 1, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, all of them have 1 electron in their outermost shell. Beryllium, magnesium, this whole group have 2 electrons in their outermost shell. This group has all 3 electrons in its outermost shell. So from the group number, you will get to know the information that these elements have these many electrons in the outermost shell, and if 2 elements have the same number of electrons in the outermost shell, it means they have similar chemical properties. Now, the next thing you need to remember from this periodic table is what are the common names of certain groups. Now, group 1 is known as alkali metals. We'll find out why they are known as alkali metals. Group 2 are known as alkaline earth metals. Group 7, that is whole of this group, is halogens, and group 8 or group 0 or the last group of the periodic table is a noble gas. And the elements which are between group 2 and group 13 or group 2 and group 3 are known as transition metals. Okay, now in the exam they can give you the periodic table and then ask you to give an example of a transition metal, a metal, alkali metal, noble gas, alkaline earth metal. So just looking at the periodic table, there's nothing to memorize in that. You can easily give the answer. Okay, now if you see, majority of the periodic table can be categorized into 2 classes of elements, the metals and the non-metals. Now you should know what is the difference between a metal and a non-metal. 2 differences I can easily make from the periodic table. There are a lot of metals than the non-metals. Metals are to the left of the periodic table, non-metals are to the right of the periodic table. Now let's look at what are some physical differences we see in metals and non-metals. When we talk about the appearances, metals are very shiny and lustrous like gold, platinum. The non-metals are dull in appearance. The position is metals are found in the left, non-metals are found to the right of the periodic table. Metals are good conductors of both heat and electricity. We'll see in metallic bonding that they have delocalized electrons, which make them very good conductors of heat and electricity. On the other hand, non-metal have no ions, no delocalized electrons, nothing to conduct electricity except graphite. So non-metals are considered as insulators. Then there are two very important properties, which is malleability and ductile. Malleable is hammering them into sheets, and ductile is hammering them into wires. So metals are malleable and ductile both. So you can hammer them to sheets, and you can also draw them to wires. But you cannot do that for non-metals. So non-metals are not at all malleable and not at all ductile. Next, all the metals, they lose electron to form positive ions. We'll see in ionic bonding. And you also know that the metal has like 1, 2, or 3 electrons in the outermost shell, which is easier to lose. On the other hand, non-metals have more than 5 electrons in their outermost shell, so it's better for them to gain an electron. So they gain an electron and form the negative ions. Now, the density of the metals is very high, and they also have high melting and boiling points, whereas non-metals have a low density melting and the boiling points. Now, the examples of the metals are sodium, potassium, that is group 1, 2, and 3 elements, and non-metals are carbon, sulfur. So group 4, 5, 6, 7 are all non-metals. Okay, so now let us see, as I told you, the common groups, and you need to remember what these group number known as. So group 0, 1, 2, and 7 is what you should know. Group 0 is noble gas, 1 is alkali metal, group 2 is alkaline earth metal, and group 7 is halogens. Now group 0, why is it called as a noble gas? Because they are stable, they have full outer shell, therefore they do not react. So what will be the properties of group 0? They are stable, unreactive, have full outer shell configuration, and are found in the last group, that is to the extreme right. Example, helium, neon, argon, krypton, xenon, and radon. Group 1 are alkali metals. We call them metals because they show all the metallic properties, and we call them alkali because they all react with water to form metal hydroxide, which is an alkali. Now, what are alkalis? Alkalis are the bases which can dissolve in water. So soluble bases are alkali. So what will be the properties of alkali metals? They are reactive. They have 1 electron in the outermost shell. They lose 1 electron to form positive 1 ion and gain full outer shell configuration by losing 1 electron. Example, list all the elements which are to the extreme left. And what are they? Lithium, sodium, potassium, rubidium, cesium, and francium. When we talk about group 2, these are alkaline earth metals. Alkaline, the reason is the same. They also react with water to form metal hydroxide. But why we call them earth metals? Because they're majorly found in rocks. And again, they have properties like the alkali metals. They are reactive, but they do not form +1 ions. They form +2 ions because they have 2 electrons in their outermost shell. So they lose 2 electrons to gain positive, to form positive 2 ion stable configuration. Example, beryllium, magnesium, calcium, strontium, barium, and radium. For group 7, it's halogens. Why we call them halogens? Halo means salt, gen means forming. So they are salt forming. They combine with metals and form salt. They have 7 electrons in their outermost shell. And as they have 7 electrons in their outermost shell, they just need to gain 1 more to have a full noble gas outer configuration. So they form negative ions. Example, fluorine, chlorine, bromine, and iodine. We'll discuss in a little bit more detail about group 1 and group 7 in this video. But all these halogens, they exist as diatomic molecule. So in the reaction, you will never see as F. You will see it as F2. You will never see Cl. You will see it as Cl2. Okay, so I hope this table is clear to you. This is very important. Make sure you remember the common names, which group they are in, why we call them with their names, and few properties of them. Okay, so now let's elaborate about group 1 and group 7 a bit. Now, when we talk about group 1, these are all the elements: lithium, sodium, potassium, rubidium, cesium, and francium. That is their symbol. You can easily see from the periodic table, and this is their electronic configuration. So lithium is 2, 1, 281, 2881. Now you can notice all of them have one electron in their outermost shell. Therefore, they all belong to group 1. Okay. Now, their reactivity increases down the group because all these elements react by losing an electron. And when you go down the group, the tendency to lose an electron increases. Now, why it increases, we'll just find out. So, if they'll ask you in the exam, which is the most reactive group 1 element, you can easily say cesium and francium. Francium is radioactive, but it is highly reactive. And then, which is the least reactive alkali metal? That is lithium. Out of sodium and potassium, which is more reactive, you can easily say potassium because it is down the group. Down the group, the reactivity of group 1 metals increases. Okay, now let us look at the physical properties of group 1. They are highly reactive. Their reactivity increases down the group. Since they have one electron in their outermost shell, they lose one electron and form positive 1 ions. They are stored in kerosene and oil. Why? Because they are highly reactive. They can easily react with air, oxygen in the air, or moisture in the air, and can cause an explosive reaction. They are soft, silvery, and shiny, but you must have seen that the metals at times look dull. The reason for that is they react with oxygen in the air as they're too reactive and forms a layer of oxides on its surface, and that oxide gives them a tarnish appearance. And I've already told you that lithium is less reactive and francesium is highly reactive. They have low melting in the boiling points, and the melting in the boiling point decreases down the group. Okay, so I hope these physical properties are clear to you. Now let us look at the chemical properties. Now in the chemical properties, you need to know about 3 reactions. Reactions with water, reactions with oxygen, reaction with halogen. Now always remember, whenever asked in the exam, you'll be writing a balanced chemical equation along with the state symbols. So here I'll be taking an example of lithium, how lithium reacts with water, oxygen, halogen. You can replace lithium with any of the group 1 element, that is lithium, sodium, and potassium, and write the equation the same way. So whenever any metal, that is M, group 1 metal, that is lithium, sodium, and potassium, reacts with water, it forms metal hydroxide. MOH is the formula, plus hydrogen. So if I take M with lithium, lithium with water form LiOH plus hydrogen. Remember, lithium is a solid, water is a liquid, lithium hydroxide is aqueous, and hydrogen is a gas. Now the question can come, what is the observation of this reaction? So you can easily say that we will see that the solid is decreasing in size or mass. And since there is a hydrogen being produced, which is a gas, we'll see the fizzing. Okay, and they can ask you the test for hydrogen. So it's a squeaky pop test. Okay, so metal hydroxide is formed, which is an alkali, and therefore they can ask you what will be the pH. So there'll be an increase in pH. And remember, the reactivity increases down the group. So potassium will react more violently as compared to lithium. When we see the reaction with oxygen, it forms metal oxides, and for the group 1 oxide, the formula is M2O. So lithium oxide is Li2O, sodium oxide is Na2O. We'll see in bonding how we determine the formulas of the ionic compound, but till then you can just remember that group 1 oxides will be of the formula M2O. So lithium, which is a solid, reacts with oxygen, which is a gas, and it forms 2Li2O, which is a solid. Okay, and when we react it with halogens, you get the metal halides. Okay, so like lithium with fluorine, remember halogens will be in the form of diatomic molecule, and it gives lithium fluoride, which is a solid. Okay, so these 3 reactions, very, very important. Make sure you remember them. Make sure you know how to write the equations along with the state symbols, and do not forget to balance the equation. Okay, now, as you know, the reactivity with the water will increase down the group. So when you have the reaction with potassium, we will see that there's a fizzing, and there's a very violent fizzing, and the potassium will quickly melts into a ball and catches fire and produces a lilac flame. Whereas sodium will react a little bit intermittently, and all of them, lithium, sodium, potassium, as I told you, alkali metals have less density. We'll see both of them will be floating in water. Okay, all of the 3 will be producing fizzing because the hydrogen is being released. In lithium, since it is not that reactive, the shape is retained and it quickly, slowly gets smaller. Whereas in sodium, it melts into a ball while reacting. So it will get deformed earlier than lithium. And potassium, it quickly melts into a ball, catches fire, and produces a lilac flame. This observation can also tell you that the one that is reacting very explosively is one of the elements which is down the group. Okay, so I hope the physical properties, the chemical properties, and what is the electronic configuration of group 1 is clear to you. Now comes a very important question. Why the reactivity of group 1 increases down the group? Okay, now in order to explain that, you need to remember that if any question comes in, you need to first explain that alkali metals, they react by losing electron, and the tendency to lose the electron increases down the group, therefore they become more reactive. Now the question is, why it increases down the group? Now, the tendency to lose an electron depends on these three factors, and all these three factors contributes to an increase in tendency of the alkali metals to lose an electron down a group. First is the nuclear charge. Now, if the nuclear charge will be smaller, the outer electron will be weakly held by the nucleus and can be lost easily. So once we go down the group, you have seen, if you see the electronic configuration of the group 1 elements, can you see that the shells are increasing? So there are more electrons that are being added. So the atom is getting bigger in size. As the atom is getting bigger in size, the outer electron is getting further away from the nucleus. So as the outer electron is getting further away from the nuclear charge decreases. The inner electrons, they are shielding the outer electron from whatever nuclear charge that is present, and bigger the size of the atom is also decreasing the nuclear charge. So due to all these factors, down the group, the tendency to lose an electron increases, and alkali metals react by losing an electron. Therefore, the reactivity of group 1 increases down the group. Okay. Now remember, when you get this question, you need to talk about these scientific terms, the nuclear charge, shielding, and size of the atom. Okay, so I'll summarize. Down the group, the atom size increases due to increase in the number of electronic shell. This results in the outer electron being further away from the nucleus. As the outer electrons become further away from the nucleus, the nuclear charge decreases. Increase in number of shells also increases the shielding and shields the outer electrons from the nuclear charge. Therefore, the tendency of an atom to lose an electron increases down the group, resulting in increase in reactivity down the group. Okay, so remember, in group 1 you need to know the reason why it increases, the reactivity increases down the group, and I hope now you're able to answer that. Okay, now the next thing we need to do is group 7. As I told you, group 7 are known as halogens, and halogens are known as salt forming. Okay, now what is the electronic configuration of halogens? So electronic configuration is that they all have 7 electrons in its outermost shell, and when they have 7 electrons in this outermost shell, they can easily gain 1 electron to gain the full outer shell configuration. And when they gain these 1 electron, what will happen? They will form the -1 charge. So these all react by forming the -1 ions. So the members of the halogens are fluorine, chlorine, bromine, iodine, and astatine. Electronic configuration 27, 287, 28, 187, 288, 1887. So you can see all of them have 7 electrons in this outermost shell. Now you also need to know what is the physical state, like how do they look like at room temperature and how do they look like in solution. So the fluorine is a yellow gas, chlorine is a green gas, and if fluorine is in solution, that if there's any reaction that results in the formation of chlorine in a solution, then it will give a pale green color. Bromine is a volatile brown liquid, but if bromine is in the form of bromine water, it will be yellow colored solution. Iodine is a volatile purple solid, but if it is in solution, it will form a brown solution. And astatine is a radioactive halogen. Again, as we discussed in group 1, the group 7 has an opposite trend in reactivity. So group 7 reactivity decreases down the group. Why? Because they react by gaining an electron and the electron affinity decreases down the group. Okay, we'll see it in detail in the next 2 to 3 slides why it happens. But if the question comes in the exam, which is the highly reactive halogen. So you should quickly answer fluorine. Which is the least reactive? Astatine. Which is more reactive than bromine? Chlorine. Which is less reactive than bromine? Iodine. Which is a green gas amongst halogen? Chlorine. So you should know about all of this. Okay. So now let's talk about the physical properties. We all know they are nonmetals, found to the right. They gain an electron from -1 ions. They have low melting and a boiling point, and their melting points and boiling point increases down the group. I already told you they exist as diatomic molecule. They are poisonous and smelly. Their reactivity does not increase down the group. The reactivity decreases down the group. Their density increases down the group, and they are poor conductors of heat and electricity. Okay, now let's talk about their chemical reactions. When they react with hydrogen, they form hydrogen halide, and these hydrogen halides, if you have a fluorine, chlorine, the reaction will be more explosive because these are highly reactive down the group. To have this reaction with iodine or maybe bromine, you might require a catalyst. When they react with metals, they form ionic compound. They gain one electron from the metals and form this noble gas electronic configuration. These ionic bonding will be discussed in more detail in the structure and bonding unit. Okay, now this is a very, very important reaction, which is a displacement reaction. And this is the only reactions in halogen which require a bit of an understanding. It's easy if you understand it properly. Now, what happens is a more reactive halogen will take the position of the less reactive halogen in its salt. Okay. Now, what is the most reactive halogen? The halogen which is at the top will take the position of the halogen at the bottom, provided the bottom halogen should be in the form of a compound. So, for example, if you look at this reaction, chlorine with NaBr, which is more reactive? Chlorine. Good. Which is less reactive? Bromine. And bromine is in the form of compound or salt. So chlorine can quickly swap the position of the bromine and form 2NaCl and displaces the bromine. And if you remember, if this reaction is in solution, you will see a yellow solution. Okay, so chlorine is being more reactive. The salt is of the less reactive halogen. So chlorine being more reactive has taken the position of the less reactive bromine in its compound. And bromine gas being less reactive than chlorine has been displaced by chlorine. On the other hand, if you do this reaction, chlorine with NaF, which is more reactive? Fluorine, is it alone? No, it is in the form of compound. So nobody can take its position because it is the highly reactive, so no reaction. So fluorine can displace all the halogens, chlorine can displace all except fluorine, bromine can displace only iodine, and iodine cannot displace fluorine or chlorine or bromine. Okay, so remember, the top halogen can take the position of the bottom halogen, provided the top halogen should be alone and the bottom halogen should be in the form of an element or a compound. Okay, sorry, compound or in the form of a salt. Okay, so I hope this displacement reaction is clear to you. Next is, again, as group 1, why the reactivity of group 7 increases down the group. So to answer this question, you will first explain how group 7 reacts. So group 7 reacts by gaining electron, and down the group, the electron affinity decreases. Therefore, the reactivity down the group decreases. Now, why the tendency to gain an electron decreases? Again, we'll be talking about these 3 scientific terms: nuclear charge, shielding, and size of the atom. As you go down the group, the nuclear charge decreases because of the increase in size of the atom. So the halogen cannot hold the incoming electron properly. So it won't be able to gain an electron with that ease down the group. Also, down the group, the nuclear charge gets shielded by the inner electron. So the incoming electron will experience a smaller nuclear charge. Okay, so I hope it's clear to you. Now let me summarize. Down the group, the atom size increases due to increase in the number of electron shell. As a result, the nuclear charge decreases. The size of the atom also increases down the group, which makes the nuclear charge weaker. the electron shells also increases, which decreases the effective nuclear charge on the incoming electron. So due to all these factors, the nuclear charge decreases, which decreases the tendency of gaining electron down the group of halogen, making them less reactive. Okay, so to summarize, we talked about group 1, group 7. These are alkali metals, these are halogens. They have 1 electron in the outermost shell, they have 7 electrons in the outermost shell. They are metals, they are non-metal. They react by losing an electron, they react by gaining an electron. They form positive 1 ion, they form negative 1 ion. The alkali metal reactivity increases down the group, and the group 7 halogen reactivity decreases down the group. The group 1 reactivity depends on the tendency to lose an electron, and group 7 halogen tendency depends on gaining an electron. Therefore, reactivity of group 7 decreases down the group, but for group 1, it increases down the group. Okay, now let's do the last topic, transition metal, which is a chemistry only topic. Transition elements are found in group 2 and 3. So this block is a transition metal. They are hard, they are strong, they are malleable and ductile. They have higher density than group 1 and group 2. Therefore, iron you have seen, copper you have seen is used in construction purposes. They are used commercially as a catalyst. They show variable oxidation state. They form colored compounds, okay? And they show the reaction of oxygen, water, and halogen like group 1, but they react slowly, so they do not corrode easily, okay? So I hope the periodic table is clear to you. Now let's quickly brush up the key terms that we saw in this unit. We discussed about the periodic table, metals, non-metal, halogens, alkali metal, noble gases, transition metals, periods, group, alkali, and the displacement reaction. Now, what is a periodic table? A periodic table is a table that shows an arrangement of all the known elements in the order of their increasing atomic number or a proton number, and the table is organized into periods and groups. Metals are the elements found in the left of the periodic tables, which are sharp, shiny, conductors, malleable, and ductile. Example, group 1, 2, and group 3. Non-metals are the elements found to the right of the periodic table, which are dull, insulators. Example, group 4, 5, 6, and 7. Halogens are group 7 elements as they are salt forming. Alkali metals are group 1, which react with water to form alkali. Noble gases are group 0 elements, which are stable and do not react as they have complete outer shell. Transition metals are the elements found between group 2 and group 3, which have high density, show variable oxidation states, and form colored compounds. Periods are the horizontal rows of the periodic table. Groups are the vertical columns of the periodic table. Alkalis are the bases that are soluble in water. And displacement reaction is when a more reactive element displaces the less reactive element from its salt solution. Okay, so all these key points are clear to you. Now let's test yourself. Now you need to look at the periodic table and give me 2 examples of each. A non-metal, alkali metal, halogens, noble gases, semi-metal or metalloid, metal that form +1 ion, metal that form -1 ion, metal that form +2 ions, and a transition metal. Next is you need to write the name of the most reactive halogen and the most reactive alkali metal. Why alkali metal gets more reactive down the group, why the halogen gets less reactive down the group, and then you have to write the balanced chemical equation, including the state symbols of potassium with water, lithium with oxygen, sodium with bromine, chlorine and hydrogen, and then you need to explain the displacement reaction of halogen with example. So you can pause the video, have a go at these questions. If there are still any question you're unable to answer, go back, look over the video again. Okay, so now let us look at the answers. So metal, these are just my answers. You can pick any. So there's no right and wrong here. Metal, there are so many metals. You can list any metal. But remember, they should be from the left of the periodic table. Non-metal, oxygen, fluorine, alkali metal, group 1, halogens, any metal from group 7, noble gas, group 8, semi-metal or metalloids, remember that zigzag, all the elements that come in the zigzag, you can name that, so that is silicon. Metal from +1 ion, it means they have 1 electron in the outermost shell, so any of the group 1 example. Non-metal that form negative ions means it should have 7 electrons in the outermost shell, so any of the halogen. Metals that form +2 ions should be group 2, so any of the group 2 you can name. Transition metals are the elements between group 2 and group 3, so you can give any example from that. Okay, so I hope you are now clear with how to read the periodic table. The most reactive halogen, remember, is the halogen, which is the top one, that is the fluorine, and the most reactive alkali metal is the bottom one, which is the francium. Why the alkali metal goes more reactive down the group? I know you know the answer. So down the group, the atomic size increases due to increase in number of electronic shell. This results in the outer electron being further away from the nucleus. As the outer electron becomes further away from the nucleus charge decreases. Now, increase in number of shell also increases the shielding and shields the outer electron from the nuclear charge. Therefore, the tendency of an atom to lose an electron increases down the group, resulting in increase in reactivity of the alkali metals down the group. On the other hand, halogens down the group, the atomic size increases, again due to increase in number of shell. The nuclear charge decreases, the size of the atom also increases, decreasing the nuclear charge, and the shells also shields the outer electron from the nuclear charge. Therefore, the incoming electron cannot be held with a stronger nuclear force. Due to all these factors, the tendency to gain an electron or electron affinity decreases down the group. Therefore, the halogens become less reactive down the group. Okay. Next is write the chemical reaction, potassium with water, KOH plus hydrogen. Remember, there'll be a fizzing. It's an alkali, so the pH increases. Lithium with oxygen is lithium oxide. It can form the layer and make the metal look dull. Sodium with bromine is a sodium bromide. Ionic compound, we'll see dot and cross diagram in the bonding chapter. Chlorine with hydrogen form an HCl gas. Explain displacement reaction when the more reactive halogen displaces the less reactive from its salt. So fluorine being more reactive is alone can displace the less reactive which is in the compound and itself form a compound and displaces the other one, so that is chlorine. But if we do it in the other way around, chlorine being less reactive cannot take the position of NaF, so no reaction. Now, whenever we talk about organic chemistry, we basically talk about hydrocarbons. Now, what are hydrocarbons? Hydrocarbons are the compounds which are made up of carbon and hydrogen only. And from where do this hydrocarbon comes? It comes from crude oil. Now, crude oil is a black thick liquid which takes millions of years to form. And the best part is that different components of the crude oil have different boiling points, so you can separate them by the process known as fractional distillation. Remember this word, fractional distillation, as often in the exam they ask you to explain and even explain the term fractional and distillation. So let's see. Now, before we come into fractional distillation, let us see what are the different properties that each of the components of the crude oil has. Now, the properties of the crude oil, it depends on the chain length. So, if the chain length increases, the boiling point increases. Now, what is the boiling point? It is the temperature at which hydrocarbon boils. It increases with increase in chain length. Why? Because greater the chain length, greater the surface area between the molecules, and higher the boiling point. Next is volatility. Volatility is a property that how quickly it can convert into a vapor. And naturally, lower the boiling point, more volatile the substance would be. So with increase in chain length, the volatility decreases. Next is viscosity. Viscosity is thickness of the fraction, and naturally greater the chain, greater is the thickness, so the viscosity increases as the chain length increases. And last property is flammability, or the property of ignition, which is how quickly something burns, and it decreases with increase in chain length, because the longer the chain length, it is difficult to burn that molecule or the hydrocarbon. So the chain length increases from top to bottom, the boiling point increases, the volatility decreases, viscosity increases, and flammability decreases. So you should know what is the meaning of all these terms and how they vary across the chain length. Now, this is the fractionating column for the fractional distillation of crude oil. Now, remember the important bits in here. At the top, we have a low temperature, and at the bottom, we have a higher temperature. So at the top, we get shorter chain fractions, and at the bottom, we get a longer chain fractions. Okay, now, what is fractional distillation? Fractional distillation is separating in the fractionating column with different substances of similar boiling point. So each fraction has the components or the hydrocarbon with a similar boiling point. So fuel oil is one fraction, diesel oil is one fraction. And distillation is separating on the mixtures of boiling point. So The crude oil has all the components which differs in their boiling point. So we can use this property by taking a fractionating column and maintaining the series of temperature. At the bottom, the higher temperature, and at the top, the lower temperature. Now we heat the crude oil at a very high temperature and put it inside this crude oil at the bottom. The vapors will start to rise, and the shorter chain ones, which has the lower boiling point, they will condense at the top, followed by the medium chain and the higher boiling point liquids at the bottom. Okay, now what are the different fractions? You need to remember these different fractions in the order. So at the top, we get liquefied gas, then we get gasoline, then kerosene, diesel oil, and residue. The liquefied gas is used as a fuel. Gasoline or petrol is used for car fuels. Kerosene is used for aircraft fuels. The diesel oil is used in diesel engines, and residue is making roads. The mnemonic to remember that is, look great, kid doing roll. So L stands for liquefied gas, G stands for gasoline, K stands for kerosene, D stands for diesel oil, and R stands for residue. So you should know this fractional distillation setup. Which temperature is at the top, which is at the bottom? What are the various fractions we get? In what order? Where do we get shorter chain fractions? Where do we get longer chain fractions? And the uses of these fractions. So this slide is very, very important. Okay, next we have another technique called cracking. Now what is cracking? As the name suggests, crack means to break. So cracking is the thermal decomposition of the longer chain hydrocarbon into a shorter chain alkane and an alkene. So you can look in this example. We have 1, 2, 3, 4, 5, 6, 7 hydrocarbon long, and we broke them into 2 carbon ethene and then 5 carbon shorter alkane. Now, why do we do cracking? And this question is also asked in the exam many times. So we do cracking because we need shorter chain alkanes, because shorter chain alkanes are more in demand because they're good fuels. And the fractional distillation alone cannot fulfill the demands of shorter chain alkane. The second thing is why we require cracking is we require alkenes for polymerization, and alkenes are required to synthesize other hydrocarbons, which fractional distillation cannot give. Okay, so you should know what is cracking. In the exam, they can give you any compound. They can ask you, write the name, write the formula for 20 carbon hydrocarbon. So 20 carbon alkane would be, we'll see later, it has the formula CnH2n plus 2. So that would be C10H42. You need to do its thermal cracking. So remove an alkene which has a C2H4 formula, and then you are left with 18 and 38 hydrogen. So they can ask you to write a cracking equation. Why is cracking done? And what are the ways in which we do cracking? Either we give a high temperature, that is thermal cracking, or we use a catalyst, which is a catalytic cracking. Okay, so I hope this cracking concept is clear to you. Now let's see what are hydrocarbons. The first family of hydrocarbons is alkanes. How do we define alkanes? You have to define it by using the word saturated hydrocarbon. Saturated means it contains carbon-carbon single bonds. You can see all these molecules has carbon-carbon single bonds. And hydrocarbons, because they are made up of carbon and hydrogen only, the general formula is CnH2n plus 2. So the first member would be CH4, C2H6, C3H8, C4H10, and pentane C5H12. So whatever the number of carbon is, you double it and add 2 for the number of hydrogen. Now, if you look at methane, ethane, propane, butane, all these members, they have the same functional group, that is, they all have alkanes. They show similar chemical properties and they have the same general formula. But they will have different physical property. As you can see, methane has 1 carbon, so it will have a shorter boiling point as compared to pentane, which is a longer hydrocarbon. So all these members differ in physical properties, and each next member differs. So you can see in this homologous series, they have the similar functional group, similar chemical properties, same general formula, but one member differs from the successive one by 1 carbon and 2 hydrogen. So CH4 add 1 carbon 2 hydrogen gives C2H6. C2H6 add 1 carbon 2 hydrogen is C3H8. So this is what is the definition of homologous series, and it is often asked in the exam. So make sure you remember this. So homologous series are the members of the same family having similar functional group, similar chemical properties, general formula, but different physical property, and each member is different from successive by CH2 group. Now, next is reaction of alkanes. Now, alkanes show only 2 types of combustion, complete and incomplete. What is a complete combustion? Combustion is when the fuel is completely burned.
So hydrocarbon plus oxygen give carbon dioxide and water, and it is not toxic as it is not producing any harmful gases. On the other hand, incomplete combustion is when the fuel is partially burned due to limited supply of oxygen. So the hydrocarbon, it burns to give carbon monoxide and water. Now, it is toxic as carbon monoxide is a toxic gas. It decreases the oxygen carrying capacity of the red blood cells. Therefore, it is very harmful and a toxic gas. So, incomplete combustion is harmful. So, in the exam, you should be able to write the equations of complete and incomplete combustion. Remember, incomplete, take the carbon dioxide and water out. And in incomplete, write carbon monoxide and water and balance the equation. Okay? Now, the next thing we need to do is how will you test the product of combustion? Now, combustion gives carbon dioxide and water. For carbon dioxide is a lime water test. You do the combustion reaction, the gas level is low, you pass it to a lime water, it will turn lime water milky. For the water test, you take anhydrous copper sulfate, and when you add water to the anhydrous copper sulfate, it will turn blue. Or you pass the water through blue cobalt chloride paper and it will turn pink. So cobalt chloride and copper sulfate is both the test of combustion products. Now let's see what are functional groups. Now we have seen hydrocarbons, and alkenes are hydrocarbons. At times, apart from hydrogen and carbon, you get some other atoms like alcohols as OH, carboxylic acid has COOOH and COO. These groups of atoms which give special properties and reactions to the organic molecules are functional groups. And you have 4 functional groups in your syllabus. Alkenes, which is a double bond. An example is ethene, propene, butene, and pentene, and we can form it by cracking of crude oil. Alcohols is a hydrocarbon chain with an OH, and we name it with ol. So 1 carbon alcohol is methanol, 2 carbon is ethanol, propanol, butanol, and pentanol, and we can make alcohol by reacting alkene with water or steam. And carboxylic acid is COOH, which is methanoic acid, ethanoic acid, propanoic acid, butanoic acid, and we get them by oxidation of alcohols. And esters is methyl ethanoate, ethyl ethanoate, and we get it by the reactions of alcohols and carboxylic acid. So now let us see all of them in detail. Now what is alkene? Now since alkene has a double bond, which makes it unsaturated hydrocarbon. So alkenes are unsaturated hydrocarbons, that is the compound made up of carbon and hydrogen only, where a carbon-carbon double bond is present. General formula is CnH2n, and it is used to make polymers, alkanes, and alcohols, and we'll be seeing next how we can do that. So it always starts with ethene, then propene, then butene, and pentene. So you draw the number of carbons, put double bond, and remember each carbon can make 4 bonds. So fill the rest of the valencies of rest of the carbons with the number of hydrogens, and you will see that the carbon and hydrogens, they'll be in the ratio 1:2. Okay. Now, what are the reactions of alkene? This is very important. Okay. Watch it very, very properly and make sure you are able to write these reactions. First is combustion. Combustion is both complete and incomplete. So you can take any alkene, react it with oxygen. If it forms carbon dioxide and water, it is complete combustion. And if it forms carbon monoxide and water, it is incomplete combustion. Then it shows addition reactions. Now, what are the addition reactions? When you react it with halogen, then the double bond breaks into the single bond, and these 2 molecules, they attach to each side of the double bond. So when you take an ethene, you react it with bromine water, and this is a test to distinguish between alkane and alkene. The bromine water is orange yellow in color, and if you pass it through alkenes, it will turn clear. So alkenes decolorizes bromine water. So you take alkene and then you react it with bromine, the double bond breaks into the single bond and bromine attach here. Similarly, when you react it with hydrogen, the double bond breaks into a single bond and each hydrogen attaches to each side. So alkene becomes alkane, and here you use nickel catalyst at 60 degrees. For water, when you react it with water, the double bond breaks into the single bond and hydrogen goes on one side, OH goes on one side, so ethene produces ethanol. So by addition reaction from alkane, you can get haloalkanes, you can get alkanes back, and when you use water, you can get alcohols. Okay, so these are all the reactions of alkene. Make sure you are able to write these whole reactions. Okay, next is very important, manufacture of ethanol. Now, ethanol is an alcohol
which we get either by fermentation of glucose, that is anaerobic respiration of glucose, or we have just seen when you take ethene and pass it through water, you get ethanol. So that is hydration of ethene. Now, hydration of ethene required nickel catalyst and a high temperature and pressure, whereas for fermentation, we require gentle temperature and pressure. The advantages of fermentation is, since you're using glucose or the plant-based sugar products, this reaction uses renewable resources, so it is less dependent on fossil fuels and make less harms and have less energy requirements. On the other hand, when you do hydration of ethene, it takes ethene from crude oil and it uses non-renewable resources. But the advantages of hydration of ethene is it's a continuous process. You can just put everything in a mixture and keep the reaction going on. It is rapid, more efficient, make more pure ethanol, and since it is the only product, it has 100% atom economy because it has no side products. On the other hand, fermentation is a batch process. You cannot make the reaction go on because as soon as the alcohol concentration increases, it will kill the yeast. So you need to make certain quantity of alcohol and distill off and then do the reaction again. So the reaction is slow, produces impure ethanol, and the atom economy is not 100%. So both of these processes has its own advantages and disadvantages, and in the exam they'll ask you to explain for both the methods, and you have to explain the reaction condition, advantages and disadvantages. So make sure you remember this table and contrast the benefits of each of the methods and disadvantages. Next is alcohols. Alcohol have the functional group OH. The general formula is CnH2n plus 1 OH. So if you take N as 1, the first carbon is methanol with CH3OH. 2 carbon is ethanol, 3 carbon is propanol, 4 carbon is butanol. So you have 1 carbon with OH and then 3 hydrogen, 2 carbons with OH and fill the rest of the valencies with OH. And the alcohols are used as fuels, solvents, and spirits. Okay, so I hope what are alcohols is clear to you and you're able to draw the displayed formula and the general formula of different alcohols. Now, the reactions of alcohol, first is combustion, as we have done alkenes. So all hydrocarbons choose a combustion reaction. In a complete combustion, ethanol or any alcohol with oxygen give carbon dioxide and water. And in incomplete combustion, any alcohol with oxygen give carbon monoxide and water. Next is the oxidation. When you oxidize an alcohol, it converts into an corresponding carboxylic acid. So methanol will convert into methanoic acid, ethanol will get converted into ethanoic acid, propanol will convert into propanoic acid. And for this, you require an oxidizing agent, which is generally the potassium dichromate. And alcohol, basically, they act as like an acid. So they react with the metal to form a salt and hydrogen. So alcohols react with metal to form a salt and hydrogen. So here we have ethanol with calcium and it forms calcium ethanoate plus hydrogen. Okay, so I hope all these reactions are clear to you. Next we have the carboxylic acid. Carboxylic acid have the functional group C double bond OH. So 1 carbon is HCOH, which is methanoic acid. 2 carbon is CH3COH, which is ethanoic acid. 3 carbon is CH3CH2COH, which is propanoic acid. And butanoic acid is CH3CH2CH2COH. Now, carboxylic acid are considered as weak acid, and they'll ask you in the exam, why is it a weak acid? So you have to give this definition that weak acids are those which are partially dissociated in water to release H plus ions. And then you have to give this equation, CH3COH breaks into CH3CO minus plus H plus. Now, since it's an acid, it reacts with metal oxides and hydroxide to form salt and water, and it reacts with carbonate to form salt and carbon dioxide and water. Okay, so I hope you remember these reactions and why carboxylic acid is a weak acid. Next is an esters. Esters are the last functional groups you need to know. It's the fruity smelling compounds which is used in the manufacture of perfume, foods, and cosmetics. They are formed by the reaction of carboxylic acid and esters to form esters and water. Now, how will you name the ester? Whatever the alcohol is, write its name as IL and carboxylic acid as OH. So, for example, if you take methanoic acid and methanol, the alcohol becomes alkyl, so that is methyl, and carboxylic acid, methanoic acid become methanoate. In the same way, ethanol plus methanoic acid, alcohol becomes yle, so that is ethyl, and methanoic acid becomes methanoate plus water. And to write its reaction, you will write the methanoic acid and methanol facing each other, remove the molecule of water, and whatever is left, join it together. Similarly, ethanol and methanoic acid, join them together, whatever is left, move the water, that will be your ester. Okay, now we have done the functional group. Now the last thing you need to do is the polymers. Now what are polymers? Now if you see in this figure, this is an individual unit, and you can see this is repeated, and this repeating unit is a polymer. So the individual unit that polymerizes to form a polymer is known as a monomer. Example, ethene. So ethene is a monomer, and the structure formed by the polymerization of the monomer is the polymer. Example, polyethene. So you can see CH2 double bond CH2 is an ethene, and it forms this polymer. Now I'll tell you the trick how you need to write the polymer equation. Always write the ethene or any alkene molecule such that there's a double bond in the center and all the groups are at the top, at the bottom, nothing to the left and the right side. And when you polymerize this structure, remove the double bond, draw the bars at the end, and then write N. That becomes a repeating unit. So for example, if the ethene molecule is given to us, then this will be our ethene, and I'll write N in front of it. And to make the polymer, I'll convert the double bond into single bond, join it to the ends, and then write N in the bottom. Now, ethene is simple. For example, you have propene. So what is the structure of propene? Propene is 1, 2, 3 carbon and a double bond, right? This is what is the structure of propene. Right? Now, how I will write it. As I told you, you will always draw this double bond at the center. So at the center, I'll draw C double bond CH, and this has 2 hydrogens. And this carbon has 1 hydrogen, and then it has CH3, so I'll write CH3 at the top. So I have it in this notation. I'll polymerize it, that is N molecule, and then when I make the polymer, I'll remove the double bond into single bond, join it with the ends, and then all the group remains the same. So if you write the notation always in this form, that a double bond in the center and everything at the top and the bottom, then the polymerization equation would be very easy for you. So you should know how to write polyethene, polypropene, and polybutene. So addition polymers, they are formed by addition reaction. They require only one monomer. Generally, it's an alkene. Nothing is lost in the reaction. Example, polyethene and polypropene. The other types of polymerization, we have a condensation reaction. It requires 2 monomers and 2 functional groups. For example, we have this molecule. We are representing it with the box as a schematic representation, has an OH at both ends, and then other molecule has C double bond OH at both ends. Now, when we put them together, we will remove the molecule of water by a condensation reaction. So OH, the hydrogen will be lost here, and the OH will be lost here. So what we are left with, O, and then C double bond O, and again C double bond O. So you can see that this is the new bond that is formed by a condensation reaction. So we have 2 functional groups facing each other. We have removed the molecule of water. A small molecule like water is lost. Example, nylon or polyester. This is between alcohol and carboxylic acid. So this is a polyester. An example is nylon. Okay, so this is the difference between addition and a condensation polymers. Addition requires 1 monomer. It requires 2 monomers or 2 functional group. In addition, nothing is lost. Here, a small molecule is lost. Addition polymers are formed by addition reaction. They are formed by condensation reaction. Now we have some natural polymers. They are found naturally. For example, complex biomolecules. Starch is a polymer made up of glucose, and protein is also a polymer made up of amino acids. So it's the other way around. The polymer is the protein, and it is made up of amino acid, and the DNA is the polymer made up of nucleotides. So you can see this is an individual glucose unit. Either they join by a straight chain or a branch chain and give rise to starch, glycogen, or cellulose, which are the natural polysaccharides. And these individual glucose are the monosaccharides. And 2 amino acids. Amino acids have the carboxylic group and an amino acid group together, amine group. When they join together, a molecule of water is lost, and it forms a peptide bond, and they are the condensation polymers. DNA is a polynucleotide we have done in biology, so it's just a brief recap. Nucleotide means a phosphate, sugar, and a base. So you can see a phosphate, sugar, base is repeated. In a DNA, the sugar is deoxyribose. Phosphate and nitrogenous bases are for adenine, thymine, guanine, and cytosine, and they show complementary base pairing principle. With adenine next to it is thymine, and with guanine next to it is cytosine. Okay, so I hope all this concept of organic chemistry is clear to you. Now you should have a go at these key terms: hydrocarbons, crude oil, fractional distillation, alkane, saturated hydrocarbon, unsaturated hydrocarbon, general formula, viscosity, flammable, volatility, fractions, complete combustion, incomplete combustion, cracking, thermal decomposition, alkenes, functional group, homologous series, addition reaction, alcohols, carboxylic acid, esters, fermentation, weak acid, monomers, polymers, addition polymerization, condensation polymerization, monosaccharide, polysaccharide, starch, cellulose, proteins, and DNA. Have a go at these terms. If you're still unclear, watch the video again and then come to the website and check the answer. So as always, our next step, check the specification, make sure everything which is there in the specification is still clear to you, and do exam questions on this topic. Okay, and do not forget to subscribe to my channel and hit the bell icon so that you get notified as soon as I put a new video. And if you have any doubts, leave a comment below and I'll reply you as soon as possible. So I'll see you next in the next video. Till then, happy revising.